You are listening to the Break Time Tech Talks podcast, a bite-sized tech podcast for busy developers, where we'll briefly cover technical topics, news snippets, and more in short time blocks. I'm your host, Jennifer Reif, an avid developer and problem solver with special interest in data, learning, and all things technology. I've been working on a content project this week that has surfaced some topics for me that we're going to cover today. First up, it's been a while since I've worked with the Neo4j Graph Data Science Library, and while I won't need it on a daily basis for my daily work activities, learning how things have changed was a really nice refresher. Next, I'm working my way through an O'Reilly book called Building Knowledge Graphs, and I'm really enjoying it. I'll give an overview on what I have read so far. To start us off, I wanted to show or discuss what I've learned with the Neo4j Graph Data Science Library. I got a refresh working on this through some content that I'm working on. It used to be familiar back when the library was a Neo4j Labs project called the Graph Algorithms Library. But a lot has changed since then. There's been official support and documentation and lots of movement, adding new algorithms and changing a little bit how things are done for optimization and so on. First off, what is the Graph Data Science Library? It is a library full of data science algorithms that are used to execute over graph data structures and show you different structures that are within your network based on the network connections in the data. It's really cool to understand more about the data based on those network connections, and that's what all these algorithms try to help you provide in various different ways and surface different network topologies. The first thing, though, to get started with using the library is that it requires you to create a projection. What a projection is an in-memory version of whatever graph you want to run the algorithm on. So that could be your full graph data that you're storing in the database, or it could be a subgraph, a piece of that data, or it could even be parts of that data with some additions that you want to not store in the graph. So for instance, I could create new properties or new relationships or new entities virtually and not actually store them in the database. Creating a projection is a way to optimize the way the graph algorithms are run on the data. So it is a necessary step in running the graph data science algorithms in the library. There are tons more algorithms in the library since the last time I was even working with it a few years ago, though I really spent this week just refreshing my memory on two algorithms specifically, PageRank and Louvain. PageRank is a centrality algorithm, and it's used as a way to understand influence in the network by scoring the number of connections for each entity and the importance of those connections. So looking at not only an entity's connections, but their connections, and so on. This is a fun one for understanding influence or popularity or really understanding breakpoints in the network. If this link disappears or this entity disappears, my graph structure probably looks a lot more disconnected. Where Louvain is a community detection algorithm, which means that it groups entities into communities based on the interactions or the connections. This is really helpful for understanding especially social structures. You'll see people cluster into groups where they have things in common or they interact with on a daily basis because of work or other things they're involved in. So this is a really nice way to look at groupings and clusterings within your data networks. There were some pitfalls when I started to look at the Graph Data Science Library recently. Some things that I ran up against that I didn't expect, or things that kind of tripped me up. The first was the difference between native projection versus cipher projection. Starting out, when I looked at the documentation, native projection was my starting point because it looked much simpler, a little bit more straightforward, fewer things you had to configure or work with or customize. And so I started there. But then digging in a little bit more, I saw that it looks like native projections, according to the documentation, will be deprecated in a future release. Not specific release information given, but the cipher projection looks like the way to go going forward. So I switched over and started looking at cipher projection, which is where you specify a cipher statement that's going to select a part of the graph, or you can also add in pieces that are not stored in the data set, and really create a custom subgraph for this. A lot more of available options for customizing the subset of data that you want to put into your projection. So it was really nice to check that out, and then also just a few more bumps along the way for getting comfortable with that. Then the other thing that I found was missing a little bit for me, probably because I'm not a data scientist, and so I don't understand what all the algorithms do just off the top of my head. But there's not really a whole lot of information out there on what problem each algorithm solves, or when or why to use a particular algorithm. The documentation doesn't really go into that depth, as it is just reference documentation, really. It just shows a single sentence on what it does, and then really shows you how to use it and the different customizable options you have. It doesn't really give you practical examples for here's what to do in this scenario, or here's how to use this specific thing for your use case, and here's what the results should look like, and here's what they tell you. I also noticed there's a lot more configuration in the new Graph Data Science library, the updates. This probably is really nice for someone who needs to customize a lot of different things depending on their data set, and tweaking algorithms and adjusting them to get exactly the things that they're looking for. There weren't that many layman's examples, and I really had to dig deeper than what I intended to get a view of what it was I was looking at. There's also not much explicitness on whether the different algorithms require a monopartite, bipartite, or multipartite graph, which just means how many different types of entities there are in the dataset. For instance, some algorithms really are designed to be run on monopartite, which means a single type of entity. For instance, only person nodes in the dataset, or only product nodes in the dataset, or something like that. Bipartite meaning two different types of entities, and multipartite meaning a lot of different types of entities. So if you have a whole product lineup and supply chain and e-commerce data set, that's probably going to be multipartite. But some algorithms are really optimized or only really work on a particular structure of graph, and there's not a whole lot of detail on what type of structure you need to be looking for, or you need to organize your data into, or create a projection for, in order to run some of these algorithms. That was a little bit of something I had tripped up on. The second topic for today is I have been wanting to read the Building Knowledge Graphs, A Practitioner's Guide book by Jesus Barraza and Jim Weber, and I really hadn't had an opportunity to do that, or hadn't really sat down to just start it, and so finally I did that. I was really excited to work through this book. I'm about 2/3 or 3/4 of the way through now. I really would like to go back over it again. I feel like a little bit this time I'm working through all of the content from start to finish, and I would like to go back and really focus in on certain things and dive a little bit deeper into the content and understand a little better what's going on in a second pass. But I really think this book is a thorough guide on everything you need to know about knowledge graphs. No matter your use case, your data set, your architectural needs, your structural needs, and so on, this book seems to cover a little bit of everything, which is really nice, just getting up and running and off the ground with this. It starts with some conceptual chapters, really goes into some technical details, walkthroughs of how to do something or what it would look like, and then also has completely separate chapters on data science integration, machine learning, and architectural topics as well. Runs the gamut on this, gives you a little bit of everything as a starting point here. It does go into some technical depth though. This is not a short format piece of content you can just read in a couple of hours. This is really thorough knowledge here. I definitely would spend some time, plan on really looking at this content in depth if you're interested in reading the book. To close us out, data science algorithms are fascinating and powerful for understanding connected data structures. I was really happy to have an excuse for a brief refresh, at least, on a couple of the algorithms. Then, knowledge graphs are a big deal right now, and the Building Knowledge Graphs book does not disappoint. It's a fantastic in-depth look at what goes into building them. Thanks for listening, and happy coding.